Welcome back. So we're going to be simplifying rational expressions that are trinomials and have exponents greater than 2. So in my numerator, I see I have x to the 4th plus 15x squared plus 50. So it's not quadratic. We would call that quartic since our highest power is 4, but we can still use our factoring techniques. Now, since this one looks a little different because of that exponent, I'm going to do this the long way using the AC method. So our AC will be 1 times 50. And so we need factors of 50. 1 times 50, 2 times 25, 5 times 10. And then as we look at this, we're trying to get middle coefficient of 15. And remember, if AC is positive, then our terms need to add to give us that middle term. So if we make both of these positive, that combination will work. So we're going to replace our middle term with these two. So it'd be x to the 4th, and that'd be 5. Now whatever your middle term variable and exponent happens to be, that's what you're going to use for your replacement terms. And so this will be 10x squared, and then remember we just bring down the last term. So we're trying to get 4 terms so we can do our factor by grouping. And again, the variable and exponents of those middle terms will be the same as the original middle term, because you want it to add up. 5x squared plus 10x squared is 15x squared. And then we look at the first 2 terms, and we want to take out the GCF, and that will be x squared. I can take that out of both. And then that will be x squared. Subtract those exponents, 4 minus 2. And then here the x squareds cancel, and we're left with 5. Now we'll look at the next 2 terms, and we can take out a 10. And remember, whatever that sign is, that's the sign that's going to go in the middle here. So we're taking out a positive 10. So here the 10s cancel, and we're left with x squared, and then 50 divided by 10 is 5. It's really important that you're taking your GCF out. Otherwise, you're going to have more factoring to do. Okay, here we have x squared plus 5. That's our GCF. And if I take it out of the first term, that leaves me with this x squared. And then in the second set, if I take it out, I'm left with plus 10. Okay, and of course, by the commutative property, you could put the x squared plus 10 first, and then your x squared plus 5. So that is our numerator. Oh, and you could have used the shortcut on this, because you really just need factors of 50 since your a is 1. But if you tend to get a little confused with your middle terms, you might want to work it out the long way. But you can see that the 5 and the 10 are actually in those spots. So shortcut is an option on that one. Now we'll factor the denominator. We have 2x to the 5th minus 50x. Let's think about a greatest common factor. They're both even numbers, so they are divisible by 2. And we can take an x out of each one. So here our 2's cancel with our exponents. Remember when we're dividing the same variable, we subtract the exponent. So 5 minus 1 is 4. And then 50 divided by 2 is 25, and our x's cancel. And here we have a difference of 2 squares. We have the dots. Even though our exponent is higher than 2, we can still do that if it's divisible by 2. So we're going to have 2 parentheses. Remember, in one set it's a plus, the other one's a minus. Square root of 25 is 5. And then if we take the square root of x to the 4th, that would be exponent divided by the root, which makes that x squared. So we'll have x squared in each. Okay, so remember the difference of 2 squares, you take the square root of each term, put that in parentheses, and then in one parentheses you need a plus and the other a minus. And that ensures you don't have a middle term, because that'd be 5x squared minus 5x squared, which is 0. Okay, so that is our denominator. Now that I have replaced my rational expressions with their factored form, I can cancel like factors. Here I have x squared plus 5 divided by itself is 1. So I'm left with x squared plus 10 over x squared minus 5 for my simplified answer. We need to think about domain, so we're going to set that whole denominator equal to 0, each factor equal to 0. So we have 3 equations that we need to solve. For the first one, we'll divide both sides by 2 and get x equal to 0. Here we'll take away 5 and get x squared is equal to negative 5. And we've learned previously that we can take the square root of both sides. When we do that, we get a positive or negative. This would be irrational. That would actually be I is the square root of negative 1, so we would just park the I in front. Okay, and we're just finding the domain over real numbers, so we don't have to worry about that, the irrational one. Okay, on the last one, we'll add 5 to both sides. And that'll be x squared is equal to 5. We'll take the square root of both sides, remembering we get plus or minus. So our x is plus or minus the square root of 5, which is irrational, but that's okay. That's still a real number. If we were to pop that in a calculator, we'd get about 2.2. That would help us if we had to graph it. So our domain will be all real numbers except 0 and positive or negative square root of 5. And that's it for that problem. Have a great day.